Hello everyone, welcome back to Dragonfly Engineering. So this week we're going to talk about the family mold that we made to create these plastic trays, and these were made for Gametammer, and I believe these are still available on Amazon if you'd like to get your own. And so this is a family mold, so two parts are molded on this mold. One is the tray here and another is a card rack here. And this is the A side and the B side. And for this episode and the next episode, we're going to focus on the tray portion of this mold, which is this cavity and this core. So stay tuned and see how we machine the A and B side inserts for this mold and a little bit of the mold base as well. Thanks for watching.
and this is a 3/16 ball end mill. I'm going to follow up with a 1/4-inch ball end mill as well. Got this long spindly tool. I'm just kind of manually machining all this. I kind of have to create a funnel and like almost like a chute for the plastic to roll up and into the cavity. So I'm going to use a few different ball end mills to create the kind of the funnel, for lack of a better word. All right, so here's our final cut, and this is a ball end mill for our kind of like a plumbing elbow for the plastic. All right, I just started this cut, but I forgot to hit start on record. So anyway, we're gonna recut, but you can see the beginning. So what we're gonna do is machine the perimeter of this insert for the A side, for the tray part of the family mold. And what we need to do is machine a precision perimeter such that this insert fits exactly into the pocket of the mold base, such that we get good registration of the cavity of the mold. So I've got the tool loaded and the program loaded, and I'm going to rerun and record the start here. Actually, since I know it's going to start correctly, we can start it at 100% rapid speed for this mill. And you'll see why it's good to slow it down when you start a program. I'm going to start the coolant, because this tool is a little dull, so it's better to have some coolant, and it's only dull on the tip, so it's good to do side milling on this to use up the flutes of the end mill that haven't been worn out on the tip. So I already machined this surface to set the 0 for the tool, so it's basically skimming along a surface that's already been machined. And then we'll pick up the excess material on the back of the perimeter of this mold insert. Hopefully we'll hear it start cutting again pretty soon, as soon as it turns that corner. Oh, well, actually I machined the back corner too to set this. Yeah. So this is one of the two A side of the mold inserts, and this is going to be a 4-chamber gaming piece, board game piece holding tray. And it was 3D machined for several days actually, using various end mill sizes. And a lot of the 3D surfaces here, these round edges, were used with or cut with like a 1 or 2 thousandths or 25 to 50 micron step over. And the machine just raster cut. There's video of that. And I wanted to, and then ultimately we are going to bead blast this surface, because this is going to be the top visual surface of the part. And the bead blasting helps make the plastic surface more uniform and hides all the sink defects or other like plastic molding issues. So the bead blast finish is usually the best. I did ask if they wanted a mirror bottom, but they decided against it. So we do have a 1/2-inch end mill that was used to take off the final landing here. So we can zoom in with this cell phone. This iPhone is actually really good for up close, almost microscopic video. So let's take a look here. So an airplane flew over. Sorry about that. Yeah, so zooming in with this iPhone here, you can see the raster pattern in the vertical wall is more pronounced. You can kind of like that grain pattern, and that's a 2 to 3 thousand step over. I think it was 3,000 step over with like a 1/8-inch end mill. And then on the radiused outer surface here, you can see the same kind of raster pattern. Now, so I did a 45-degree one direction, and then I recut everything faster with a 45 degrees in the opposite direction. So you may be able to see some of that in the detail on the side walls here. Now this top surface, I just machined flat using a 1/2-inch end mill. So you can see kind of the traditional just 2-axis machining that was caused by the 1/2-inch end mill, and then the 3D raster profiling, which took a couple of days to do using a 1/8-inch end mill that had a crosshatch. In fact, I think you can see the 2 diagonal parallel paths that were taken to cut this shape.
So if we go along, you can see the kind of the effect of the 3D raster cut. Vertical walls have more kind of vertical lines. Now when we bead blast this with high pressured air and approximately 0.5 millimeter diameter glass beads, a lot of these tool marks will be obscured by the bead blasting and you won't really see it. Here's a junction where 2 cuts occurred or several features met. So this is the result of a few days of 3D machining. You can see some areas take to the 3D raster better than others. Like this surface here, you can see the micro scallop height is what it's called, where basically the round cutting tool is trying to cut a surface, but the round shape can never really be taken away, and the remnant shape is called the scallop, and that's that little grain pattern you see in this round surface. So anyway, next step is I'm going to mask off the shut-off surface of this insert, which is this surface, with basically white masking tape or with white duct tape. And that will allow the glass beads to bounce off of the mask, but actually where there is no rubber mask, the beads are going to dent into this aluminum and create like a frosted plastic EDM almost look. So let's do that next. So this is the white 3M duct tape that we're going to use as our bead blasting mask. And again, it's a bouncy surface. I always have trouble ripping this stuff. So wherever the glass beads hit this duct tape, it's going to bounce off and not dent the aluminum. And wherever there's just aluminum exposed, the glass beads will put a little tiny dent into the aluminum surface. And you multiply that by a couple of million, and you'll get the bead blasted finish that we are shooting for, excuse the pun, for this plastic part. And the more I can refine the leading edge of our mold cavity, the better off we are when we're molding these parts, because we'll have a cleaner, sharper parting line here, so there'll be less flash and less of a noticeable transition or parting line in the molded part when the 2 mold halves come together. As this corner gets dented and rolled over, then the result is you get a little edge of plastic that's molded in that fills in that rolled over edge. So after we're done bead blasting, even with putting this protective cover on the edge, I'm going to skim cut this top mounting surface or parting line or parting surface of the mold to create a new razor sharp edge along the side so that the plastic part has a nice cleaner parting line in it. You know, so the more I can protect this edge before I skim cut, the more true the dimension of this plastic part is going to be. You know, because I am actually going to probably take off 2/1000ths off of this top surface, which means that our part is going to be 2/1000ths shorter than the design. But that doesn't matter really with this. It's kind of a cosmetic part in that regard. Okay, so now we'll mask the ends. Here I'm going to use scissors to try to get it in close. As soon as I figure out where I put the scissors. Okay, and then we just kind of spray over the whole thing with glass beads. And that's it. So it could be, so it may be hard to see the tool blend that I'm talking about from the flat machining surface to the 3D profile. But I bet this cell phone can show the difference. So let me, let's do the video. Yeah, you can definitely. So as I fly along the top of this mold, you can see this line that's pronounced. That I need to scrape out, maybe just with a razor blade or the edge of a new sharp parallel or a lathe bit. You can see how it diminishes over here, so you can't see anything. But on this side you can see that, you can definitely see the tool blend mark. Not sure why that's there. It could be that the block moved in the mill as I was doing this final cut, or it could be end mill flex, where the end mill flexed such that it blended on this side, but it didn't blend over here. But let's see what I can do to get rid of that. Okay, so I got the cell phone and the regular camera looking at this operation. Not sure if you can see the line that I'm dealing with, but what I'm doing now is looking for a nice sharp edge on one of my new parallels, or newer parallels. Okay, so the idea is that we want to get rid of the blend mark, which is approximately right here on the corner of this parallel that I'm using. And I am going to use the sharp edge of this parallel, which is kind of a new parallel, and use it as basically a planing tool. And I'm going to plane off the aluminum surface around this line, or this notch that we see in the surface of the mold cavity, with pretty light pressure. And you can probably see that there's two lines forming, and the blend problem, or the indentation, is that bead blasted line in the middle that's surrounded by the sharp, shiny edges of the aluminum that we're cutting using the edge of this 90-degree parallel with a nice, almost razor edge on the end of it. And I'm just kind of blending in these surfaces, and it's a tricky balance, because you don't want to take off so much metal that you create like a lensing effect or an indentation that's visible to the naked eye after we bead blast this surface. So sometimes you gotta stop short of getting rid of the entire little blend line there. And you also want to feather the surfaces, kind of almost like you're finishing body filler on a car hood or something. I've already done the previous section over here out of camera, but I was doing it while the iPhone camera was looking at the wrong section. So I am going to clean up over here. You don't want to have abrupt like gouge edges either, because then you got to spend time to clean that out, like I almost did right there. So let's see how that looks after we bead blast. I have trouble saying bead blast. Let me roll this up. You may not be able to see the line too well with the camera, but I can see it. I can see half of it on this final bay. So as I scrape across, yeah, you can probably see, yeah, there you can see the original blend line. And I've basically highlighted both sides of that line, which is on the radius, with our scraping tool, basically. I guess it's for lack of a better word, it's a blending scraping tool. And I'm just kind of shaving off a few tenths at a time, or a few microns per pass, and it's basically just aluminum dust that's coming off. And by bead blasting, you are creating high points and valleys, and those high points do shave off easier. So hopefully that took care of it. Do this one. This one doesn't look as bad down here. The tool blend that we're looking at could just be thermal drifts in the spindle when it was doing the couple of days of raster cutting. The spindle slowly gets warmer and warmer over time, even though there's a chiller keeping it cool and everything, but it's hard to hold microns over several days. And what we're seeing is probably 10 microns or 20 microns. It's hard to say. I think the other side looks okay. Yeah, this side doesn't look bad. All right, so there's the touch-up that we did on the surface on one side only. So let's go back to the bead blaster and refinish our mirror finish that we cut into this edge to clean up that line. You can see a little bit of the line, but I think it'll be obscured enough by the bead blast. If not, then we'll repeat this process until you can't see it. All right, so back in the bead blaster, or sandblasting cabinet is what some people call it. Let me get this out of the way. Okay. So this should be pretty quick. We don't want to overdo it either. We also don't want to peel up our mask in the corners. Okay, here goes. I can still see some of the shiny poke. All right, I think that definitely helped it out. It's probably below the threshold of being able to see it, especially after we mold it with a gray plastic or a tan plastic. Let's see what we got. Okay. Yeah, I can still see some remnant of it here. I may have to sand this and bead blast it again to get rid of all the evidence. But that's the process. Okay, I did a little bit of sanding with some of this fine grit sandpaper. What was it? 180 grit. And then I re-bead blasted, and now we can't see any of those tool blend marks anymore. So that's good to see. So it's time to peel off our duct tape mask here and see how our transition line looks. I could see some evidence of beads getting under there, but not too bad. And again, we're gonna fly cut with a shell mill this top surface to get a razor sharp edge here. But it looks like it didn't really affect the surface too much. Some of that is just dust getting under there. So, let's see how we're looking. Yeah, so basically we've got the frosted look for the mold cavity, and then the shiny precision parting surface, which is that mirror look. And the whole idea is to get a razor sharp edge right here where my thumb is, or basically along this edge here. We want that as sharp and strong as possible. So, next step is to basically plane off about 1 or 2 thousandths off of this top surface here.